Ball A, which has a mass of 2 kilograms and a speed of 9 meters per second, collides with ball B at a 55-degree angle. Ball B is initially at rest and has a mass of 2.5 kilograms. The collision causes ball A to travel 35 degrees to the right at a new speed of 4 meters per second. Calculate the velocity of ball B after the collision. The first step to solve this problem would be to break the vectors up into their components. The x and y component of ball A's initial velocity will be 9 cosine 55 and 9 sine 55 respectively. The x and y component of ball A's final velocity will be 4 cosine 35 and 4 sine 35 respectively. The x and y component for ball B's final velocity will be denoted as velocity final b cosine theta and velocity final b sine theta.
In order to solve for momentum in the x and y direction, we can assume that due to the law of conservation of momentum, that the initial momentum of the system in the x direction will equal the final momentum of the system in the x direction. It is also known that momentum is equal to mass times velocity, so we could go ahead and set up the momentum equation. Using the definition of momentum, you could set the initial momentum of object A and B equal to the final momentum of object A and B. At this point, you could just go ahead and plug in the known values that were given and solve for the x component of object B, which gives us a value of 1.508 meters per second.
Now that we have found the velocity of ball B in the x direction, we need to find the velocity in the y direction. To do this, we use the same law of conservation of momentum equation as before, but incorporating the values in the y direction. After rearranging the equation, velocity of ball B in the y direction can be solved by multiplying the mass of ball A by the initial velocity of ball B minus the mass of ball A times the final velocity of ball A, which is all divided by the mass of ball B. After plugging in all these values into the calculator, the velocity of ball B in the y direction is 4.062 meters per second.
Once you find the x and y component of velocity, after using the conservation of momentum, you use the Pythagorean theorem to find the resultant vector of velocity of ball B after the collision. 4.3 meters per second due to sig figs. But since velocity is a vector, you also need to find the direction, which is the angle at which ball B bounces off. You take the inverse tangent of the x and y component of velocity to find the angle, which is 70 degrees. Misconceptions that could have occurred while solving this problem is 1. Remembering to split up the vectors into components. 2. Keeping track of your values so you don't plug in the wrong component in the equation. And 3. Velocity is a vector, so you need to make sure to solve both magnitude and direction, speed and angle.